OK。大丈夫ですか？
はい、大丈夫です。
始めますか？はい。
じゃあ、
Hello、Steve Carroll と申します。私はちょっとだけ日本語ができますから、この発表は残念ながら英語の発表です。私は.NET プラットフォームのディレクターです。開発のディレクター。So yes, I'm going to switch over to English at this point. Thank you for your patience with that Japanese. So I have been at Microsoft for about 17 years. I'm a manager of developers at Microsoft across our languages and developer tools, basically that whole time. Currently, the .NET platform team, which is my team, consists of the application frameworks, which is ASP.NET, the EF Entity Framework product, WinForms, as well as Mono, the libraries, so all like system.everything, core CLR, as well as the Roslyn team are all part of the .NET platform team that I'm the director of development for. So the goal of today's talk is in about 45 minutes, I want to give you a broad overview of the latest releases with a focus on what I think are some of the areas that perhaps more advanced developers will want to dig in more on. This is a sort of unique talk. It's one I kind of made myself out of all the pieces. Today's about quickly laying high-level context of what the current moment in .NET is about, and then give you a bunch of pointers for areas so that you can decide to drill in more. So at various points inside this talk, I'll give you URLs or other places to go look for things so that you can learn more. The talk will only have a few demos in it, but lots of callouts for places and resources to go learn more about parts of the relatively large .NET 5 product. So we're now just a few weeks after .NET 5 has launched. And so there's a whole wealth of information out there. And it's my goal is to give you a whirlwind tour that will hopefully make you more aware of what's in that large amount of materials and focus on what's really most relevant to you as a developer. Okay, so that's the pitch. So you've seen this slide before, probably, if you've seen a .NET talk. I wanted to put it up here because I look at it as a quick reminder of what our broad mission is, and I think it's a good framing for thinking about what we'll be talking today. So this is a quick reminder that our broad mission is that we want you, the developer, to be able to transfer your skills from one place to another. We want you to be able to learn a language, be it C#, be it VB, be it F#, learn some of our languages, learn some common libraries, learn some tools, and then be able to really build any kind of application. We look at it as our job to continually add the cool new things that you want to be able to build. And we'll talk about some new ones today. .NET enables developers to be more productive, building feature-rich applications of any type for any device with great performance. Before I jump into .NET 5 itself, I just want to take a moment and talk about our momentum. I want you to leave this talk with a strong feeling, a strong understanding that the skills you're taking time out of your day, I think on a Saturday, right, to build using .NET will continue to be useful into the future. And so I think it's really important that we always stress that we are seeing significant growth. .NET as an ecosystem has a ton of momentum. One of the things that you see on the screen that I'm most proud of is actually that for the last 2 years in a row, .NET Core has won the most loved framework in 2019 and 2020 on the Stack Overflow. Our open source projects, .NET and ASP.NET, are both some of the highest velocity OSS projects, i.e. The ones with the most amount of actual work going into them. And also, we're built for speed. We have the Tech and Power benchmarks. We continue to make progress. I'll go into more detail about that soon. So the next thing I wanted to just talk about briefly is just our adoption. There are now 5 million .NET developers, active developers. That means you use it at least a few times a month, using it across the Visual Studio family. And so that means Visual Studio for Mac, and Visual Studio Code. We see 5 million unique developers a month. That's over 1 million new Visual Studio .NET developers just in the last year alone. And 600K of those were in .NET Core. Another thing I'd really like to make sure that we have people understand is that one of our biggest areas for growth is people doing .NET on Linux. I think in the old days, it was very common for people to think of .NET as primarily a Windows technology. We've done a lot of work to make sure that that's no longer true. So as of 2 weeks ago, there are 2 in-support versions of .NET Core released just in the past year alone. 3.1 is an LTS release. LTS stands for long-term servicing, i.e. that one is the one that will be in support throughout 2022. And .NET 5 is the latest release, so that's the hottest one. And you can see we have 2 different links there, depending on which one you want to go and get. So let's talk a little bit about the wave of releases starting from 3.1, and then we'll build towards what's come out in .NET 5. So the first thing I wanted to talk about, it will directly relate to that mission I talked about at the beginning. One of the cool new things to build is machine learning. Adding machine learning into existing applications is one of the things that we see .NET developers most excited about doing right now. And data science is super cool. But what we don't want is for you to, either A, you have to become a data scientist to build custom models, and we don't want you to have to learn how to use Python just to access ML scenarios in your existing application. So what we've built is a thing called Model Builder for ML.NET. This is now released, and it's actually built into Visual Studio. So if you have Visual Studio 16.6 or later, this is built right in there. You can go in and do a new ML.NET Model Builder. It's built with Azure AutoML. Azure AutoML basically explores different machine learning strategies and algorithms for you. You give it the data, you give it a little bit of information about the type of your data, and then it can help you wade through all the very many different kinds of machine learning strategies and get something up and running pretty quickly. So we've added a lot of new common AI scenarios. If you've looked at it before, the UI is getting more and more easy to use. And so I'd really encourage you, if you're interested at all in enlightening your existing applications with machine learning, to take a look at ML.NET. And if you search for ML.NET or Model Builder, you'll see some good trainings on how to get this going. And that's been out for the last few months. The next thing I wanted to stress is that in the 16.6 version of Visual Studio, we have now made the Windows Form Designer generally available. So we're basically saying it's fully ready for people to use. It's out of beta. This adds the .NET Core support. All of the toolbox controls that you love are available, and third-party controls are supported and coming soon. We're seeing lots of excitement from the control vendors about selling WinForms controls, and so I expect to see this continue to be a growing area of the ecosystem. One of the things that came out slightly after 3.1, we updated 3.1 to include it, is Blazor WebAssembly. So if you haven't seen Blazor yet, as a refresher, Blazor is a full stack solution for building web UI with .NET and C# instead of JavaScript. It gives you support for building Blazor applications, which originally shipped in .NET Core 3.0. But in that one, we had a model that we called server hosted. We call it Blazor Server, where all of the UI interactions are handled over a real-time connection with the browser. Now, with Blazor WebAssembly, you can run your Blazor app purely client-side using a WebAssembly-based .NET runtime. Blazor WebAssembly enables you to run .NET standard libraries directly in the browser using just open web standards. There's no browser plugins required. It's not like Flash or anything like that, or any sort of code transpilation required. It's real .NET running in the browser natively. Likewise, this is a case where we've been lucky enough to see a lot of partners getting into the Blazor game. Blazor has a very nice control model. If you were a fan of web forms back in the day, I definitely encourage you to take a look. And we have many partners releasing support for Blazor, WinForms, and WPF on .NET Core in their tools and controls today. For those folks, if any of you are in the room, thank you. Really excited about all of the vendors putting things out to help you build better applications. Likewise, if you are excited about Blazor, I would like to point you to many of the things in our growing open source ecosystem. If you're starting or growing a Blazor app, I'd recommend taking a look at this link I have at the bottom, aka MS Awesome Blazor. So if you can remember that or take a screenshot, You can look for inspiration or incorporation of many different open source projects. There's a lot of great samples in there, a lot of great middleware, things that you can use to make your application even better. So all of that is supported on the 3.1 version, which is, again, a long-term servicing release version. But at this point, I'm going to start transitioning to talking about our first .NET 5 thing, which is we took .NET 5 Blazor WebAssembly and really improved it quite a bit in .NET 5. So it was about a half of a year's worth of work that went into the .NET 5 version of this. The biggest change is actually the unification of the full .NET 5 libraries with Blazor. In the 3.1 version, it uses a sort of separate version of the libraries, but now there's sort of full .NET 5 unified libraries, as well as some tools that will help you identify any cases where there's compatibility issues. So definitely really strongly encourage anybody who's building a Blazor application to try out the .NET 5 version. The other huge change in this is performance, and that's what these graphs that you see on the right are. There's two things that we want to talk about here. One is sort of just the speed of handling JSON, which is, of course, the language of the web in a lot of ways. We've gotten that to be quite a bit faster for serialization and deserialization, which is improving the speed of these applications. And the thing on the bottom is about the rendering performance of Blazor applications in the browser using WebAssembly when we have like what we'll call like a very big stress test of a grid. So the idea here is we really wanted to prove to people and get our performance right so that you could really believe that we have enterprise level scalability in these applications. They will render fast even for very complex line of business applications. But there are lots of new features based on feedback from users, such as component virtualization, which was a big one, CSS isolation, lazy loading for improving the load performance, and lots of progress on our tooling. Razor tooling has gotten a lot better. Okay, so I'm going to keep going with that now. Let's start diving into all the different parts of .NET 5 that we've improved and start looking to see what new scenarios are on offer. So one of the things I'm most proud of in the .NET 5 release is all of the performance improvements that we've been able to bake in. We did work from the top of the stack to the bottom of the stack in the frameworks, in the libraries, in the runtimes. But on this slide, I'm really stressing work that we did to improve our core web performance and modern microservice performance factors, because that's where some of our largest wins are. It's where we focused most of our attention. The first thing is, again, another example of a place where I want to stress that we are taking Linux seriously. We improved socket performance improvements, just all socket performance, 30% on Linux over .NET Core 3.1 from a year ago. JSON serialization performance has improved over 19% compared to .NET Core 3.1. And the thing I want to actually point out here is we track a total of about 104 different serialization benchmarks. Literally every single one improved between .NET Core 3.1 and .NET 5. Likewise, we've done a bunch of work to make serialization of large collections and arrays improved. Those are 3x, and in most cases, they will not allocate memory. So that will be a big and important thing for many large applications. But finally, I want to pause a minute and talk about the improvements that we did in gRPC. These graphs that you see before you are a little complicated, so I'm going to slow down for a second and explain what you see here. Unfortunately, there is a naming nightmare. The one on the left, which is called grpc.net.client, that is the .NET 5 library for gRPC. And the one in the middle, grpc.core, that's actually the like raw C version of it. It's actually like language bindings on top of the raw gRPC library. And finally, on the right, you can see is our actually Go language performance. So what I want to stress here is you've got both on client as well as server. In all of these cases, these are requests per second. And of course, higher is better. And so you can see that especially under heavy load, such as 70 concurrent requests or 28 connections, you can see there is a significant performance boost on client and a significant boost relative to 3.1 on the server performance as well. And the other thing I'd like to point out is in both of these cases, our performance actually exceeds the performance of Golang, which a lot of people think of as a high performance language. .NET can definitely beat it in many cases. Okay, I'm going to keep going on .NET 5 performance. First thing I do is I want to stress a principle, which is that many important Azure services these are large cloud scale services being just at world scale, such as Bing, such as Cosmos DB, and more every day. We work very closely with them to make sure that we can measure our performance on there, because anytime we can save those teams' performance, we can save the company money. And so that focus is something that then leads to these performance gains that then you can use in your own company's workloads. So we work very closely with those teams. Many teams inside Microsoft are already running on .NET 5. They've been improving their workloads at scale, and that should make your code better too. More data on that to come, but as an example, Bing saw noticeable improvements in P95 and P99 load times based on some GC improvements that we made, and significant CPU and memory usage reductions in production that are just saving them tons of money. The next big resource I want to get you excited about that I hope that you will go off and read, especially if you are a performance person inside of your company or somebody who aspires to become an expert for .NET 5 performance. If you go to this aka.ms link, you will find a blog post that details everything that either my team or the community did for performance explained. It walks you through both what the performance improvements were and how we did it. This is a great way to educate yourself on how to improve your own C# code, because of course, all the principles that we're applying there, they're just as appropriate for your own code base. And so they're a great educational tool. I hear from people all the time about what they've learned from them. Okay, but the next thing I want to show you is something new that's built into Visual Studio. I love this demo. That you can turn on to find known perf wins in your code base. So just, I'm going to switch over to VS at this point. And is that it? There it is. Okay, hopefully you're seeing it. So first thing I did is I went into the project file, just basically right click properties. I went into the code analysis selection, and I did enable .NET analyzers, and I set them to latest. What this will do is it will turn on our best performance analyzers. When you do this the first time, it will actually go and fetch them. And then it will automatically start running these as part of your build using Roslyn analyzers that tell you all about the performance problems that we now know about. So you can see inside this little test program I have, there are many errors already identified. One thing to be careful here, watch out for, is most of them are informational level. So if you have information turned off, you will not see them. So I'm going to bring you and show you some examples of what these look like. So the first one I'll show you is a really straightforward one. As you can see here, we have a simple function that calls process.getCurrentProcessID, current process, and then the .id value on what gets returned from that. So as you can see, there's a light bulb. And if I click on the light bulb, it will tell me that I have violated code analysis number 1837, and that indeed I should be using environment.processID instead of this. So what happens here is this API is much cheaper. And so it does exactly the same thing as calling getCurrentProcess.id, but of course we have a cached version of it. And so therefore it will save you a lot of time, especially if you call this thing in a loop. So one of the things I think is beautiful about this is you can actually just click, apply the fix. As you can see, it just replaces the code right there. So that's beautiful. Another example of that is right here in this previous one. Here we are all we're doing is comparing count to 0 to see if something is empty. And as you can see, it says always prefer is empty over count to determine whether the object contains items or not. And again, reason is simple. It's faster. And if you call this in a loop, it could make a big difference. So there are many of these. They cover all sorts of different situations. I think about 90% of them have an automatic fixer. So you can just go in and click fix, and get, and, you know, of course, as a former profiler tooling owner, I say, and then of course you should measure that it worked, but we're pretty confident with most of these. These should be very high confidence rules for you to try out. Another set that they're in here will detect that there were stack allocations and loops, which is another thing if you're trying to make your code low allocating. Okay, back to the slides. Right. So again, those analyzers, all you have to do to get them is go into your projects and you have to turn them on. They will be off by default. Okay, I'm not going to go into detail on C#9. I know that there is a talk later in the day about C#9, and I don't want to steal too much of the thunder, but I did ask the team to give me some high level stuff that they wanted me to highlight. So just briefly, these are the top line numbers for, top new features for .NET 5. Records, which allows a shorthand declaration of immutable types with value semantics. These are great for reducing risk. They're safer. They help you to prevent a lot of nasty bugs that occur when you update your objects. They work well with EF Core. I strongly recommend checking these out for making your own immutable types. Top level programs, the design point behind this is we want it to be as simple as possible for you to learn .NET. A lot of this was done for making it easier for students or for samples. So that now the following program using system and console.writeline hello world is a valid program in C#. You don't need any toss that into a function for any reason. You just type what you need and you can .NET run that and it will work perfectly. There are a lot of good enhancements to pattern matching. I know that the first application I wrote in pattern matching when I was doing my 3.1 usage, there were a few things where I was just, oh, okay, you can't match on that kind of pattern. I went back and I checked after 5.0 and using C#9, and so many more of them worked. I like, in particular, I think this letter 1 here at the bottom is very, very useful. You just say C is greater than A and less than Z, or greater than capital A and less than Z, and that will do exactly what you expect. So before I get off C#9, I just thought I would bring the perspective of my own teams to you and say that these were the features that we were excited to see more usage of than we expected when we added them. We basically wrote interop features for ourselves, right? We needed them inside the libraries and in order to make a bunch of scenarios that my team cares about improving, better. But actually, these have gotten a lot of interest from developers all over. And so I just wanted to let people know that if you had ever wanted function pointers to be a thing, now in C#9, it doesn't show up in the intro to C#9, but they've been really popular. Likewise, skip locals init. If you put that attribute on a function, it will indeed skip initializing the locals, which can be very useful in interop layer code for performance. And we've added a native int and a native uint that will match whatever the platform that you're on, which can be very useful for writing interop code. And finally, we're really excited about source generators. Source generators allow you to add C# constructs, classes and methods at compile time. And so what we're seeing this happening is a whole bunch of exciting new usage of these that we didn't even dream of at the time that we started designing this feature are starting to bloom across the ecosystem. And what we're seeing is a lot of things that people are today using runtime reflection, so like ref emit scenarios, are now trying to move those from runtime to being compile time. And so again, I won't go into detail here, but I would encourage you that if you're interested in that concept of moving runtime reflection scenarios into compile time, search for the Source Generators Cookbook in the Roslyn repo. And there are a bazillion best practices as well as examples of different scenarios that we've seen people do. And that thing is getting expanded all the time. So definitely check it out if you are interested in runtime reflection and making it, getting the cost of it out of runtime. Okay, as I mentioned at the beginning, my team also owns the libraries. And so I wanted to go through some of the things that I've never seen, highlighted in a talk, but that I think many, I want you to know are there so that you can go check out more about them. So the first thing is we got the base class libraries, i.e. system.star, to be about 90% nullable annotated in the release. I think where we actually landed was 93%. What this means is that if you just build and turn on nullable and run it against your code, you will find null pointer exception bugs that you did not know about. That is my guarantee. So this is great. If you're using it in 3.1, you will just find way more bugs in 5 because much more of the class library is now annotated. So A, go find your bugs. B, there's a call to action. If you happen to be a owner of a library, a .NET library, we are really excited now that we have the bottom layer all annotated. We're hoping that people who own the layers on top of that, such as those libraries, will go in and do that annotation themselves. And all of this together will come and help us remove so many bugs from production. So yes, please, by all means. We continue to expand system.text.json APIs for highly requested scenarios. I would just want to stop here and stress that the intention with system.text.json is not to completely replace the Newtonsoft JSON. It's a completely different design point. The intention is that system.text.json will always be high performance and high scale. We will add scenarios as long as we can do them without sacrificing perf and scale. But there are many new things in there that were requested. So please, by all means, check out. If you weren't able to use system.text.json in your 3.1 applications, check again, see what we've added for 5, see if you can move. And give us feedback if there's something that you really need. Half precision floating point types are absolutely fantastic for machine learning scenarios and other numerics. Those have been added into the libraries for your use. Likewise, we have made significant investments into several modern web standards. So I talked about gRPC a little in terms of its performance improvements. We've also made functionality improvements to HTTP2, such as the heavily requested multiple connection support in HTTP2. Likewise, in TLS, which is important security API surface, we've made a lot of improvements. We've added 1.3 support, and inside our authentication support, we've given you finer grain control over that authentication. Likewise, we've done a lot of work to enlighten for information, underlying information of the garbage collector. So there are lots of new members on GC memory info. And so if you are a performance tuner, this is something you should definitely go and check out. Likewise, we continue what we call the spanification of .NET Core. We have added so many new span-based APIs. These are great for writing high-performance code. We've added them in the areas of sorting, in the areas of parsing, and formatting more types. So by all means, look for these as opportunities. And I'll give a call back here to say that you'll see a lot of this in that blog post we talked about earlier that shows you how to use span to get some of the wins that we had in .NET 5. Okay, there are a bunch of HTTP client convenience APIs that were added for serializing and deserializing directly to and from JSON. So I give you a beautiful little snippet of code here where you just take the service URL, you new up a HTTP client, and then it's as simple as just client.get from JSON async, and you can give it a strongly typed type that matches what the JSON URL will return. And it is so much easier than having to hand roll this. So the thing, I call this a convenience API because, hontoni benri desu. But at the same point, this is much cleaner code. And we have designed it such that it will be much less error prone. You will get fewer need for thinking hard about error conditions and such. Likewise, we have added a highly requested feature to allow you to customize the transport layer that is used by the HTTP client. Continuing on with our theme about making Linux first class in .NET Core, we've added role-based authentication in the system.directory-services.protocols APIs. Another thing I like to do, especially when I'm in a non-English speaking country, we got a lot of requests for having better control over the localization and the ability to customize it. So for instance, if you were working on Windows before, we used the Windows localization APIs. But in .NET 5, we now have consistent localization by default, where we use the ICU library for doing localization on Windows as well as Linux. And also we allow you the ability to build your own ICU library and provide it along with your application if you want to customize how localization works for your application. For instance, it's very common for people to want to ship only certain locales because ICU and localization information can be large and can make up a big part of your application. If you are excited about data science, the data frame APIs ship out of band as a NuGet. So I would suggest you look for data frame .NET APIs, and you'll find some good samples and some good NuGet packages. Finally, this is a very deep cut, but CBOR and ASN.1 readers and writers. I will be honest, I too had to look this one up. But they are data formats that are used in many protocols. And so if you have protocol code that you had to write yourself, but it's really based on these CBOR and ASN.1 formats, this is an opportunity to get rid of a lot of error-prone parsing code in your own applications. Okay, next big topic, cloud-native investments. So we want .NET to be the most productive and up-to-date place to build cloud-native applications. So we're going to focus on that category of apps for a few minutes. Our investments cross a few different categories: platform updates, new middleware, and also new tooling. So one thing I really want to stress is our increased integration with the OpenAPI ecosystem. It's much easier to use OpenAPI or Swagger and that stuff, if you've heard of that. In .NET 5, we do API REPL. We can generate clients. And there's a really nice workflow if you want to publish to Azure API management as you start to move your application to take more advantage of cloud-based patterns. And indeed, the API management tool is a real useful cloud pattern. We talked a little bit about gRPC contract-based APIs. You can generate clients and servers from a proto file, and we are working on world-class performance, as I showed you some data earlier. And finally, under platform updates, I want to talk just a minute about making microservices actually micro. So in a minute, I'll go through some data on the work that we did to create single file axes. And top-level C# programs play into this too. We want you to be able to just make these little small applications, just like you can do in something like Go, where you can just build something and deploy it and not think about it and have it be small and compact. Okay, middleware. So just taking a minute here, we're building a high-performance reverse proxy. We call it YARP, which stands for Yet Another Reverse Proxy. Ha ha ha. And you can see here, I've given you the URL for what to search if this is a pattern that interests you. Basically, the origin of this is inside of Microsoft. We saw 3 or 4 different teams going off and building their own reverse proxy from custom and from scratch. We asked them why. They said that they needed one that was more easily customizable using .NET code. And so we basically took the unification of all of those different reverse proxies and built a great .NET pluggable reverse proxy. So whenever we see a pattern like that repeated multiple times across multiple teams and multiple products that are doing completely different things, we wanted to make sure that we open sourced that. And so we're really excited about this super high performance reverse proxy that, again, is in production, sitting in Microsoft, having lots and lots of traffic go through it. Okay, and then tooling investments. We'll get into this more for a minute, but I'm going to want to talk a little bit about WSL2 and Linux, and I want to talk about opinionated .NET microservices and orchestration tools with the Tide project. But first, single file and trimming. So we shipped a form of single file axes in .NET 3.1 or 3.0. Basically how it worked was it would zip all of the stuff into a single exe. And then when you ran the exe in the background, it would unpack everything into a folder in the background. This solved some people's problems, but it wasn't enough for this scenario of microservices that we really wanted to solve in .NET 5. And we also put a ton of investments into the IL linker to improve the performance and usability of trimming. So the IL linker is a tool that will trim out unnecessary unreferenced code, and it makes a huge difference. So basically anything that you don't reference from the framework won't get packed into your application once we can prove to ourselves using heuristics that it won't be used. And also you can give the linker hints and say like, okay, yeah, but I needed this one. So let's look at this data for a second here. This is a complicated table, but just so you understand what we're doing here, we're showing Linux versus Windows. We're also showing self-contained versus normal single file. The difference between these two is in self-contained, it also includes the framework code itself, whereas single file assumes that you've already done a machine-wide or local deployment of the framework separately. So needless to say, single file without self-contained is always smaller than self-contained. So you can see like the smallest one we've actually hit is when you turn on the trimming with the IL linker and you do a single file deployment on Windows 10, we've gotten it down to under 10 megabytes that you can have a fully self-contained application there, or sorry, a fully single file one. And the smallest that we could do on Windows is 16.2 megabytes, and then we'll pack the framework into there and all the parts of it that you need. So we're pretty proud of that. R2R, if you're wondering, is ready to run. And those are those sort of pre-compiled versions. So it makes the thing bigger, but it also makes it start up faster. So that's a trade-off that you can make. And you can basically choose how to combine assembly trimming versus member trimming versus ready to run. They have different performance characteristics. And so we basically give you the option to figure out how you want to apply that for your specific scenario. New diagnostic tools. Let's talk about tools. Easier than ever to get the data you need and analyze where you want it. So for instance, you can use the .NET GCDump global tool from the .NET command line. And GCDumps can all be analyzed in Visual Studio now. Likewise, we wanted to take away all the complexity from cross-platform dump debugging. So now you can grab a Linux dump and open it inside of Visual Studio. You can take a x64 dump, an x32 dump, doesn't matter. Cross-platform dump debugging is available in 16.8, which I think is out now. Likewise, .NET Trace brings back assembly load debugging. If you've been a longtime .NET developer, you'll remember the Fusion style, the Fusion log viewer. This brings that type of diagnostics into the core world in a different way. .NET Monitor is a new tool for collecting logs, traces, and process dumps using a simple REST API. It's a global tool that can be used from the CLI. And it's also really cool about this is that you can actually get it as a container. And so you can deploy this diagnostics tool next to your application, like as a sidecar container, which is a really neat new pattern that we're excited about. And I know there's also another talk about diagnostics that will go into, I'm sure, much more detail about this stuff later today. And finally, we really wanted to unlock the open telemetry ecosystem for your .NET application. So the Cloud Native Cloud Foundation project that defines a vendor neutral specification for distributed tracing. There's a whole bunch of tools. There's a whole bunch of, now you can mix and match .NET stuff with other Cloud Native CNCF tools. We do this using system.diagnostics.activity. ASP.NET Core and HTTP client are now instrumented by themselves. So this puts together a lot of new open telemetry based scenarios are possible for doing your live monitoring. So the call to action here is, of course, for those library authors who I was talking to earlier, please consider instrumenting your libraries. This works in .NET 5 as well as full framework 4.8. So we really want people to use this. Okay, WSL2 and Linux for .NET devs. WSL is magical. WSL stands for Windows Subsystem for Linux. We believe that Windows boxes can be the best dev boxes, even for devs who are targeting Linux. So what is it? The Windows Subsystem for Linux, I want to stress, is not a VM. It is not a virtual machine. It runs natively on the hardware as a subsystem under the Windows 10 operating system. The thing I'm calling out here is the fact that we've moved from WSL1, which was released a few years ago, to just the last few months. WSL2 is now fully available. You don't need a special version of Windows 10. If you're up to date on your Windows 10 version, you should have this. It does need to be turned on. And there's all sorts of documentation on the internet about how to get started with this, so I won't go into the details. It has much faster file system performance when you're using Linux file system with Linux. It has full system call compatibility. You can do crazy mixed Linux and Windows stuff straight from your Windows laptop. So yeah, just check to see that you're on build number 2004 or higher for Windows 10. And I really strongly recommend this if you're looking to move to Linux deployment of your application. .NET Core debugging is also now available for Visual Studio. You can actually debug the Linux code from your VS running on that same Visual Studio implementation. So you get simple F5 support while you're doing debugging of Linux. It's beautiful. No remote debugging or anything. Just happens right on your box. It's a super smooth and simple scenario. Okay. And let's do a quick time check. Yeah, I'm about to the end here. So I want to just show you some really quick VS new productivity features, some things that are exciting for .NET developers. But before I do, I want to draw your attention to the URL at the bottom of the screen, github.com/KendraHavens/productivity features. Kendra Havens is a PM on the Visual Studio team, on the .NET tools for Visual Studio team. She keeps up to date a GitHub repo that gives demonstrations for all of the new productivity features that are added in each and every version, little dot version of Visual Studio. And they are wonderful walkthroughs. I'm going to show you one in a minute for this. What I would strongly encourage you, if you want to be a hero for your team, if you want to be the guy who teaches all of the cool new features of VS to your coworkers, you can use this file for and go through and give brown bags. It's really, really great. So let me just demonstrate it rather than talk about how great it is. Oh, that's the wrong one. Productivity features. Okay. So here you can see I have that productivity features project. I cloned that repo. I have it open. You can see that this is the new features in 16.8. Here's the new features in 16.7. Here's the new features in 16.6. To get started, small one, but very, very, very heavily requested you can now specify in your editor config file. And if you haven't looked at editor config file yet, I strongly recommend it. It's super great for setting up the editor with this in a way that is the way you want it. And you can actually add file headers automatically, just one click to get that right. So that was a big, well-requested file. My personal favorite is, you can see these sort of grayed out things here. These are called, what do we call these? We call these inline parameter names hints. As you saw on the slide, this is off by default. You need to turn this on. It's in Tools, Options, Text Editor. Honestly, I just usually type Advanced. And then C# Advanced. There's a whole bunch of fun tools in here. This is Display Inline Parameter Name Hints. You can turn on parts of it, the whole thing. It's great. So what it will do is, especially if you're reading a code base that you've never seen, that you're just not comfortable in yet, it will tell you, well, okay, what's this string? Without having to do a whole bunch of hovering, you can immediately see that this is the category, this is the check ID. You can see these all over. Date time. var is also, it says that var is of date time type. So very useful for navigating new, fresh code that you don't know. I love this feature. Likewise, we've continued to build in new helpers for when you are doing date time construction. Any place where there's like a weird format you have to remember, like regexes or date times, we've been adding in these helpers that help you know what each of these mean. So you can see if I click in here, it'll give me an example, and it'll help me format up my date time formats. So that's really cool. Those are the main ones I wanted to talk about today. Let's just go back to the slide for a second here. you can see there's a lot of new extract base class was very requested. Likewise, C#9 features like pattern matching. There's a lot of helpers in there to help you kind of refactor your way into pattern matching. It's really, really useful. Okay, one last thing I want to talk about, which is Project TIE, which is service discovery via configuration conventions. We hear that people want to get started with microservices, but actually getting the whole thing mapped out, it can be a lot to learn. It's easy enough to do a single project, but when you start getting multiple microservices that you need to orchestrate together, we wanted to make that easier for you to build, debug, and deploy. I'm not going to go through a full TIE thing, but if this is a problem that sounds important to you, by all means, check out Project TIE. It's in our kind of experimental phase, but there's a thriving community building around it. And I'd really encourage you to check it out. So service discovery via configuration conventions, you can add dependencies like Redis without writing Docker files. You can use it to start up multiple projects at the same time. It automatically handles the connections between the ports and the URLs of each. You can run and debug locally using containers and Kubernetes, and it gives you a local dashboard for metrics, logging, and debugging. So that you can sort of interact with those pieces of the microservices and have them sit on your one dev box, but actually work together. Then you can actually Dockerize and deploy your service straight to the Azure Kubernetes service. So it's a really nice convention for how to build microservices that has all the patterns built in. It makes it easier for you to reason about your application and debug it. Okay. So before we get done here, I just want to stress that the .NET schedule, we are now aiming for this very regular schedule. The next time you will hear from me, I hope, is next year at this time, when I'll be talking about .NET 6.0. .NET 6.0 will again be an LTS, which people remember is long-term servicing, which means that one will be in servicing for 3 years. Whereas .NET 5 will go out of servicing when .NET 6 ships. We wanted to give you a predictable schedule. We could potentially do minor releases, but the major releases will be planned for, and we've done it twice now. So I think we're going to be able to stick to this, and hopefully this predictability will be useful as you plan your applications, as you plan your deployments, as you plan your own upgrade cycles. And with that, I'd just like to kick it open to Q&A. 日本語で大丈夫？みんな、質問がありますか？聞こえますか？森さん。I can't hear you.
はい、ありがとうございます。
あ、
QA ですけども、まだ何か質問ありますかね。
今、YouTube コメントがあります。
そうなんです。YouTube コメントがね。
チューミングは安定しましたよね。漢字が難しいですね。でも。そうですね。Source generators 便利なのはわかるけど、あんまり気楽に使うと後で痛い目を見かないとして。Did you guys get any questions, or should I just wrap up for now? 皆さんぜひ質問を。Yeah, thank you. Oh, that's Inoue-san. Okay. クレマさんは質問考えてなかった。Q&A です。Any issue ICU and NLS compatibility? I'm not an expert, but I believe that you can always fall back to the old behavior. We really wanted you to be able to make sure that you could use the old behavior. We didn't want people to get lost on it. But by default, we give you ICU. So like we've seen situations where /r/n, like where it parses it differently in ICU versus the native Windows stuff. Yeah. So, okay. Second question. YARP は Microsoft 社内で使っているところはありますか？はい。Yeah. So, YARP is being used inside of Microsoft, or at least is being prepped for use. It is actually based off of a code base that we took from the Dynamics team. Yeah. So it's being heavily invested in across a number of different divisions. And our team is sort of the hub of that. But it's an open source project, and so if that's something that's interesting to you, you're going to continue to see it evolve. We're really excited about it. しまった。日本語で書いていってしまった。大丈夫です。Yeah. 日本語ちょっとだけでも読めます。
はい。じゃあ、こんなもんでしょうかね。質問の方は。
そうですね。
はい。じゃあ、ありがとうございました。
ありがと
う。改めて、アメリカからわざわざ夜遅くにセッションありがとうございます。
そうですね。今何時ですか？9時です。
東京はまだ2時ですから。はい。じゃあ、そういうことでですね。じゃあ、ここで一旦、休憩を挟みたいと思います。再開はですね、14時5分を予定しております。14時5分からはですね、次は亀川さんのセッションになります。それでは10分間休憩にしたいと思います。ありがとうございました。